Hello everyone, I hope all of you are doing good. In this video, we'll talk about very interesting topic. In the continuation about our previous video, it was related to determine the absolute configurations. And we are using this method that is called as a configuration method to determine the absolute configurations to distinct between the Fischer presentation and the Newman presentation. In this video, we'll talk about a very interesting at the same time a simple trick when the molecules they are represented in a Fischer and the options they are provided in some different formats, how we can take the help of this method. So let us take a first example. The question is the Newman projection of the following compound is, and in this case we are finding it as a part of the question or molecule is provided in a Fischer form. The Fischer projection is given for this molecule and all the options they are provided in the form of Newman projection. So in this case, the two things that we need to understand because here we need to be careful about the two things, particularly in a Newman projection. First thing is which carbon is front carbon and which carbon is a rear carbon. That is the thing. First of all, we need to take care about these two things, the front and the rear carbon. And second thing is we need to assign the numbering to chiral centers. So in this case, this will be the second and this will be the third. So here we'll find out the absolute configuration for C2 and C3. Then accordingly we'll understand how we can assign the configuration for these four options. So first of all, for this C2 center, as we know, the OH will have first priority. Here we are making a distinction between a CS3 and this group. So the C2 carbon is attached to CS3 as this carbon is attached with the three hydrogens. While on the other hand, the C3 carbon is attached with the oxygen and carbon. So of course, this group will get the second priority and a CS3 will be the third. Hydrogen will have a fourth priority. So in this case, first, second and third. So this will move in clockwise direction. So we can expect that this will be R, but the hydrogen here we are observing that is towards observer. So R will change to S. At C3 we are finding OH will have first priority, and again in this case as we are finding the C3 it is attached with the C2 which is attached to oxygen and carbon, while this CS2 is attached with the CS3. So this group will get the second priority and CS2 CS3 will have a third priority. So for the C3 this will move in a clockwise direction, so it seems to be R since it is clockwise, but again in this case the hydrogen is towards observer, so this will change to S. So in this case the absolute configurations of given molecule is 2S and 3S. Is a 2S and 3S. Now we'll go with the simplification of this options. In this case we are seeing that before to this, we'll try to understand what is the exact meaning of Fischer. So wherever we are seeing any molecule, for example, in this case, if we are writing any molecule which is having two chiral centers, then we need to understand a concept that if it is like this, so this is the plane that we are considering, this is the plane, and for this plane, we are observing this molecule from the top. So therefore, this A, B, C, D connectivity, let's say, they are towards observer. Since we are observing this from the top, so these four connectivities, they are towards observer. And this X and Y, these connectivities, they are away from observer. So this molecule, and again in this case, we need to identify that This AB we are mentioning with the part that which is on the left hand side and right hand side, and accordingly we will write the Fischer. So most important thing is to write a particular structure in this form, we need to convert the Newman in a way so that we can visualize the molecule like this. So how we can do this? For that reason, we need to put the X and Y systems like this. So the either of the groups, they should be eclipsed so that we can see this molecule from the top. For that reason, what we'll do, as we are having this front carbon is already placed in the appropriate or the required condition, that the OH is downwards and the CS3 and H, they are appropriately placed. Only the thing is the rear carbon we need to change. So we'll change like this. We'll rotate the carbon-carbon bond in a way so that the rear carbon will get rotated in a way that the hydrogen will get eclipsed with the OH. This OH will get at this position, and the CS3 will rotate in a way so that it will attain this, so that it will get convert in this form. And this OH, the front carbon is as it is, there is no change, and we are changing the rear carbon, so the hydrogen will come to this place, OH will come to this place, and CS to CS3 will be here. As I said, if we are considering this plane, we are observing this molecule from the top. So we'll write corresponding Fischer like this. As for this front carbon, OH, since it is away from the observer, so this will be at the bottom. On the right hand side, we are having the CS3, left hand side, we are having hydrogen. For the rear carbon again, hydrogen, this hydrogen, since it is away from observer, so therefore it is at the top. And on the right hand side we are having the OH, left hand side we are having the CS2, CS3. So we'll assign the absolute configurations as per the CRP rules that we have discussed earlier. So again, here we need to give the numbering. So this is a C2 and this is a C3. C2 carbon, one is OH, second will be this group, and third will be the CS3. So this will move in this direction. So we are seeing that C2 will be, as it is moving with clockwise direction, so it seems to be R, but the hydrogen is towards observer, so therefore R will change to S. So the C2 center is S configuration. At C3, OH will be the first priority. This whole group will have a second priority, and the CS2, CS3 will be third, and hydrogen will be the fourth. So in this case, first, second, and third. So this will again move in a clockwise direction. Hydrogen is already away from observer. So this will be as it is. We are having the C2S and C3R. So this is the configuration. If you are comparing with our compound that is having both the configuration S, so here is one of the configuration is R. So therefore this option is ruled out. We'll do the similar exercise for this. We'll rotate the rear carbon connectivity so that we can convert this with our required Newman projection, and we can write its corresponding Fischer. So in this case we'll write like this. So front carbon is unchanged. The rear carbon we are having the OH. Here it is hydrogen. Here it is a CS2, CS3. So as again we need to understand, we are observing from the top, considering this as the plane. So we'll write the corresponding Fischer like this. For the front carbon, CS3 at the bottom. On the right hand side we are having the OH, left hand side hydrogen. For the rear, at the top we supposed to write hydrogen, then on the right hand side it is a hydrogen, left hand side it is a CS2, CS3. As we are getting this particular Fischer, the next thing is we need to give a numbering C2, C3. Again, with the same thing, will your priorities. OH will be the first one, this group will be the second, and the CS3 will be third. So this will move in anti-clockwise direction. So we are expecting it to be S since anti-clockwise, but the hydrogen is towards observer, so S will change to R. What about C3? OH will be the first. This total connectivity will give 2 because this is attached with the oxygen and this CH2 is attached with the carbon. So therefore this will have a third priority and hydrogen will be the fourth. So in this case, first, second and third. So this will move in a clockwise direction. So the C3, this seems to be R as it is a clockwise, but the hydrogen is towards observer. So therefore R will change to S. Again in this case, we are finding one of the configuration is R. Therefore it is not the correct answer. For the C3, we'll do the similar exercise. We'll convert the rear carbon connectivities through the rotation in a way so that we'll write the corresponding structure like this. As the front carbon, you are observing the front carbon is as it is, there is no change, and this is the rear OH, rear CS2, CS3, and this one is the hydrogen. As we are observing this molecule from the top, so we'll write like this. As the front carbon, OH is at the bottom, CS3 on the right hand side, hydrogen on the left hand side. For the rear carbon again, this OH will be at the top, CS2, CS3 is at the right side, hydrogen on the left hand side. So here again we'll find out the absolute configuration. So this is C2, this is a C3, for this one this is a 1, and this one will be the second priority, CS3 will be the third, and hydrogen will be the fourth. So in this case, this will move in a clockwise direction. So we are expecting C2 is with the clockwise direction, but the hydrogen is towards observer, so therefore R will change to S. And for the C3, this is the OH will be the first one. This group or this connectivity will given be with the second priority, CS2, CS3 will be the third one, and hydrogen will be the fourth. So in this case, we are observing this will go in an anti-clockwise direction, so it seems to be S, but the hydrogen is towards observer, so therefore S will change to R. So again we are finding the one of the configuration is R, that is both are not S. So therefore this is not the correct option. So finally we'll move to the last option and it's expected to be correct, but we'll confirm it. Similar exercise will rotate the rear connectivities in 60 degrees. So we'll write the corresponding structure H, OH, CS3, CS2, CS3. Okay, here just change. As we are rotated, so the rear carbon we supposed to write, so this will be the OH and this will be the hydrogen, this will be CS2, CS3. So as we are observing this molecule from the top, we'll write corresponding Fischer. So for the front carbon, this is the hydrogen. On the right hand side, we are having the OH, left hand side, we are having the CS3. For the rear carbon, at the top, we should write OH, on the right hand side hydrogen, on the left hand side CH2, CH3. So in this case again we'll give the numbering, that is the C2 and C3. So in this case OH will be 1. This group, since carbon is attached with the oxygen and carbon, you will get the second priority and CH3 will be the fourth. So this will move in anti-clockwise direction and hydrogen is already away from observer, so C2 will be S configuration. There is no change in configuration. At the C3 we are observing OH will be the first one, this group will be the second, CH2 CH3 will be third and hydrogen will be the fourth. So in this case first, second and third, so we are observing it to be clockwise direction, but the hydrogen is towards observer, therefore R will change to S. So here you are finding both the C2 and C3, they are with S configuration, so therefore it is matching with the given compound, so therefore D is the correct answer. So in this way, if those students or those who are not able to convert the Fischer structure into corresponding Newman or Newman into Fischer, those students they can take the help of this corresponding method, that is called a configuration method. And the advantage of this method is we'll have accurate confirmation of the molecule, since we are dealing with the absolute configurations. This method is more accurate compared to interconversion, because in interconversion under the pressure of examination, some of the times even though doing a small mistake, that will lead to the wrong answer selection. So it is always recommended that we should go with this configuration method. Second example, in this case we'll follow the similar kind of methodology. The question is like this: the following Fischer projection when converted into Newman projection is correctly represented by which of these options? Okay, so here again we'll follow the configuration method. Students, if you are thinking that if you want to get the other method, that how we can convert directly Fischer into Newman, that can be also studied. But as we are studying this R and S configuration in detail, I am discussing this. We'll have more videos to get the another tricks to convert, but right now we are just focusing on this configuration method. So in this case, first of all we'll give a numbering. So this will be the second chiral center and the third chiral center. So first thing is we'll identify and determine the absolute configuration for the C2 and C3 centers. For the C2 center, OH will be the first one, and this C2 is attached with the C3, which is attached with the oxygen and carbon, while the COOH, as we know, the COOH, as we have discussed earlier, that when carbon is having double bond with the oxygen, it is considered as it is attached with the two oxygens and this third oxygen. So the COH will be as good as it is attached with the three oxygens. So this will get the second priority, and this group will get a third priority, and the hydrogen will be the fourth. So in this case, first, second and third. So in this case, the rotation is in anti-clockwise direction. It is in anti-clockwise direction, but the hydrogen is towards observer, so the S will change to R. What about C3? OH will be the first priority. OH will be the first priority. This group, here we are observing the carbon is attached with the oxygen and carbon, where the CH3 is carbon attached with the three hydrogens. So therefore this will get the second priority, and this will be the third, hydrogen will be the fourth. So the first, second and third. So again this will move in anti-clockwise direction. So we will expect that it is the anti-clockwise direction means it is S. But again here the hydrogen is towards observer, so therefore S will change to R. So we are expecting that both the absolute configurations they are determined to be R. So accordingly, as we have seen earlier, We'll do the similar exercise. In this case, the advantage or the easier thing for us is already the connectivities. That means the front carbon and the rear carbon. And one more thing that we need to understand, as I discussed earlier, here you are finding to confuse the students, as you are observing in the first option, the front carbon where you are finding the carbon is attached with the COH. So in this case, the C2 and C3, you are observing the C2 is the front carbon. While in the second example, you are finding that the C3 is a front carbon. So many of the times if students they are not identifying the exact understanding about the front carbon and the rear carbon, then it will be more difficult and it's not easy to write the structures Fischer into Newman and Newman into Fischer. For that reason, as I discussed, the configuration method will be always, it will be more appropriate and accurate. So we'll not mind regarding which is the front and the rear, as we are following the configuration method. We not worry about which is the front and which is the rear because we are giving the numbering. So only the thing just I wanted to highlight. So we'll go with the direct understanding about how we can convert it. Here we are finding the set of connectivities, they are already eclipsed. So what we'll do, we'll just rotate the whole molecule. Whole molecule will rotate as you are considering this molecule. We'll rotate the molecule in this direction so that it will look like this. We'll not change anything. We'll rotate the molecule as it is provided in Newman so that the hydrogen will be here, OH will be here, COOH will be here. We have just rotated the whatever the representation we have provided, that's Newman, we have rotated this. So the front carbon will be like this, hydrogen OH and COH, and the rear connectivity will be the same. This will be the hydrogen, and in this case it is a CS3. And as we have discussed, considering this plane, we are seeing this molecule from the top, so we'll write directly the Fischer projection of this. So the front carbon is at the bottom, it is a hydrogen. On the right hand side we are having the OH, left hand side we are having COOH. As the rear carbon at the top, we need to write hydrogen because it is away from observer. On the right hand side we are having the OH, left hand side we are having CS3. So we'll find out the absolute configuration, but before to this we'll give a numbering. As you know, in this case the numbering has to start with this, as this is just given in an inverted way. So we'll give a numbering C2 and C3 like this. So C2 center we need to match with the compound which is provided. If it is matching, that C2 and C3 is matching, then that will be our answer. So we'll identify this C2, we are finding this is the OH will be the first one, COOH will be the second, this group will have a third priority, hydrogen will be the fourth one. So in this case OH, COOH and this one. So this is moving in clockwise direction. So C2, we are seeing that this is moving in a clockwise direction. Hydrogen is already away from observer, so C2 will be R. C3 in this case, we are finding the OH will be the first priority. This group, as in between the CS3 and this one, the C2 is attached with the oxygen and carbon, so therefore this group will get the second priority, CS3 will get the third priority, and hydrogen will get the fourth priority. So for the C3, first, second and third. So again in this case we are finding it is a clockwise, hydrogen is already away from observer, so this is R. So very interesting thing is we are directly getting our answer that C2 and C3 are both configurations are R, and that is matching with our compound. So at this moment also we can confirm that our answer is this one. But just to get into the exact idea, as I said, we need to be careful about each and every mark. And of course, before going for the examination, we are doing the practice. So we'll also solve the other options also, and we'll confirm why first option is the correct one, why not the others one. So in this case, as we are doing, we will do the same exercise. As this molecule whole as it is will rotate in 60 degrees, and we'll convert this into a format that is of our requirement. As the front, this is the hydrogen, this one will be the OH, this will be the CS3. As we are talking about this front carbon, we are rotated, so this hydrogen will come to this place, OH will go to this place, CS3 will do in this way, and of course the rear carbons accordingly it will change, because we are rotating the whole molecule, not a single carbon. We are rotating front carbon as well as the rear carbon. So as the rear carbon will have the same connectivities as eclipse in a given structure, so this will be OH and rear will be the COOH. As we know, we are seeing this molecular top from the top considering this plane, so we'll directly write the structure. So for the front carbon, at the bottom it is a hydrogen, on the right hand side we are having the OH, left hand side it is a CS3. For the rear carbon, hydrogen is at the top, on the right hand side it is a OH, left hand side it is COOH. So in this case again we need to be careful about giving the numbering. Here you are finding the C2 is at this place, C3 as at like this at this place. So as I said, these problems they are very much confusing, and for that reason if you are taking the help of configuration method, I'm sure this will be more easy. No need to think about any convergence. This method is a very straightforward. So here this is our C2 and this is the C3. So C2 first priority will be OA, second priority will be COA, third priority will be this group, that is the C3, and the fourth priority is the hydrogen. So in this case this will move in anti-clockwise direction and hydrogen is already away from observer, so C2 will be S configured. What about C3? Here you are observing OH will be the first priority, C2 that means this group will be given a second priority, CS3 will be the third one, hydrogen will be the fourth. So in this case first, second and third. So here we are observing this is moving in a anti-clockwise direction, hydrogen is already away from observer, so this is S. Both the centers they are with the S configuration, they are exactly opposite to the given compound, so this is not our option. In the third case, as we have seen in the previous molecule, the rear carbon is already as per the requirement, so we'll change the front carbon connectivities in a way so that we can convert into a Newman, so that we can see from the top as per the requirement in a Fischer. So we'll rotate the front carbon is 60 degrees. So this will come to this place, this will come to this place, and we'll write like this. Hydrogen will be here, COOH will be here, OH will be here, and the rear connectivities they are unchanged. Okay, so again we need to understand always how we are seeing the molecule. We are seeing this molecule from the top, so we'll write the corresponding structure. The front carbon is this one, at the bottom hydrogen, on the right hand side we are having the COOH, left hand side it is the OH. For the rear carbon at the top we are having the OH, right hand side the CS3, left hand side it is the hydrogen. Again the thing is we need to give a numbering. If you remember in the first video I mentioned the significance of numbering. So here it is a C2, this is a C3. As you are looking toward the first, second and third option, it is always a confusing state. So we need to be more careful about the numbering. The C2 center, first priority will be OH, second priority will be COA, third priority will be C3, that is this connectivity. So this will move in anti-clockwise direction, and hydrogen is already away from observer, so C2 will be S configured. In this case, since it is moving in an anti-clockwise direction, hydrogen is already away from observer, therefore it is S configured. C3 center is, first is OH, second is of course this connectivity, third one will be the CS3, fourth one will be the hydrogen. So this is the first, second and third. So here we are observing this is moving in an anti-clockwise direction. So it seems to be S, but hydrogen is towards observer. So therefore S will change to R. And you are finding that one is S, one is R, and the expected is both has to be R. So therefore this is not the correct option. Last one again, we'll do the similar exercise. The rear carbon is already placed. We need to convert the front connectivity by rotating through 60 degrees. We can do that part. So we'll write the structure like this. This is the hydrogen. This will be the OH. This will be the CS3. And the rear connectivities, they will be as it is. So again, we need not forget the thing that how we are observing the molecule, because that is much important. Okay, so we'll write the final structure over here. The front carbon, at the bottom it is a hydrogen. On the right hand side we are having the OH. Left hand side we are having the CH3. Rear carbon, the top we supposed to write the COH since it is away from observer. On the right hand side it is a OH, left hand side it is a hydrogen. Again, the most important part is we need to give a numbering. Here you are observing C2 and C3. First is the OH, second one will be the COA, third one will be the C3, that means this connectivity, and fourth one will be the hydrogen. So this is the first, second and third. So we are observing this is moving in anti-clockwise direction. Anti-clockwise direction means we are expecting it to be S. But here the lowest priority group, that is hydrogen, it is towards observer. So therefore S will change to R. For the C3, first one will be the OH. Second priority will be given to this connectivity, that is the C2 carbon, and third will be the CS3, and fourth one will be the hydrogen. So this is the first, second and third. We are observing that this will go in a anti-clockwise direction. Hydrogen is already away from observer, so therefore this will be S. So here you are observing one is R and second one is S, and our requirement is both has to be R. So this is not the correct option. So again, with the help of this example, we are confirming that the configuration method will be more easier to understand to confirm the accurate answer. And this will be the, I think, again I repeat, for the competitive examinations under pressure, I think this method will be more accurate. Dear students, if you feel that this content is useful, please share with your friends. At the same time, subscribe the channel if you are not subscribed. Keep your valuable comments, suggestions in the chat box so that I will come to know about your requirements. Most importantly, I am thankful to all of you for watching the videos and encouraging for the next content. At this moment, thank you so much. Take care.